All right, this next problem is number 6 from the Unit 10 lecture examples, and it's a three-parter. So we'll start with part A, and it says if 45 milliliters of 3.0 molar aluminum hydroxide, so that's 45 milliliters of 0.30 molar aluminum hydroxide reacts with 75 milliliters of 0.15 molar HCl. So that's 75 milliliters of 0.15 molar. How many moles of aluminum chloride are produced? So we should recognize that anytime they tell us about both of the reactants, that we are dealing with a limiting reactant type problem. So which of these reactants am I going to run out of first? And that will dictate how much aluminum chloride I can produce. So I'm going to find how many moles of each reactant I have. I will see how many moles of aluminum chloride that would correspond to. The lower number will be what is actually obtained, and the higher value is that will indicate which reactant is in excess. So we have 45 milliliters molarity, and let's just recall that molarity is equal to moles per liter. And so that if I multiply molarity by the volume in liters, that will equal moles. And I need to, I guess, balance that equation, right? So we've got 3 hydroxides, 3 chlorides, and I'm going to rewrite water as HOH. And the OHs came from the hydroxide, so I need 3 of those. So I'm going to go 3 there to balance the chlorides. And then that gives me 3 hydrogen ions and 3 hydroxides, which means this is going to produce 3 waters. And now it's balanced. So first, let's figure out how many moles of aluminum chloride can be produced from the aluminum hydroxide. So we're going to divide that by 1,000 to make it liters. So 0.045 liters times 0.30 molar gives us 0.0135 moles of aluminum hydroxide times, now it's a 1-to-1 ratio between aluminum chloride and aluminum hydroxide. So that means from this amount of 0.30 molar aluminum hydroxide, we can obtain 0.0135 moles of aluminum chloride. Then exact same thing for the HCl. It's going to be, so divide 75 mils by 1,000, you get 0.075 liters times 0.15 molar, and that would leave us with 0.0125 moles of HCl. Then we're going to multiply that by, it's a 1-to-3 ratio between aluminum chloride and hydrochloric acid, and that means we're going to get 0.00375 moles of aluminum chloride. So we've identified this as our excess reactant and this guy as our limiting reactant. So the answer to how many moles of aluminum chloride can be produced is 0.00375 moles. And that is part A. So we will clean up the board and go on to part B. We want to know what is the concentration of aluminum chloride in the solution produced.